All right, so we are going to look at computer network, and this is a way of actually enabling us to share information and other advantages that might come along with it. So when we talk about computer network, there are various things that we are going to look at. Yeah, of course, there are technical terms that we'll try to understand as we proceed. Now, when we talk about a computer network, basically this is a connection between two or more computers. Now, talking about computers alone cannot really form a network. So we are going to look at a good term that you will be using to associate any connected device, and that is the node. So any connected device within a network, that's a node. To ensure that we have a good communication within a network, we need to have a standard or a common protocol that is going to enable this particular fulfillment of computer network. Yeah, so we're going to look at a variety of things such as protocols. We're going to look at the OSI model. We're going to understand the various types of networks, and of course reasons as to why we really require a computer network. And of course we're going to look at the both wired and wireless media form of connecting the various devices within a particular network. So to start us off, what is a network? You've already defined what a network is, as simply as a connection of two or more computers. Of course, there is always an objective towards that. So what is the objective of connecting these computers together? One, for us to be able to share information, right? Of course, right now what we are doing is sharing. Yeah, we are sharing information through a lot of things. Yeah, we have hardware in place. We also have some softwares in place, right? To quickly distribute new information. Of course, when you have internet, we can easily distribute information and also consume information from the internet. And of course, as I mentioned, right now we are connected based on different infrastructure setting. Yeah, of course you can hear my voice over data. Yeah, so that's what networking helps us to achieve also. Now, another advantage, or the reason as to why we need a network, is to access remote software applications. Of course, we are using Google Meet, and this one helps us to remotely access Google Meet. Yeah, we don't know where it is. It is in some server somewhere. Yeah, but we can actually be able to get the information locally by viewing whatever I'm displaying. Now, of course, talking about accessing software and hardware, also this one, it helps us minimize cost. Yeah, like for example, there's no need of purchasing a lot of printers. Yeah, you can only purchase one printer and share it across multiple or many people. Yeah, of course, during coordination, you see, when you connect different devices, you can easily manage them. Security wise, you can secure the devices, yeah, and so on and so forth. So we have reasons as to why we need to network computers. Of course, most of us, we don't fully utilize this particular usage of networks. We just think that maybe network is internet. Yeah, so there's more to networking than just accessing information. Now, so what are the building blocks? What are the architecture of a computer network? Of course, we have the hardware that runs behind these particular networks, and of course, we also have the softwares. Now, talking about hardware, we say that these are tangible components that you can be able to touch, you can be able to see, and so on. We have not yet talked about software, but software also comes into play when you want to network. Yeah, Google Meet is a software. Yeah, things that you can't really lay on our hands. The computer you're using, it could be a smartphone. Yeah, that is a hardware. Yeah, the cable, even if you're using Wi-Fi, yeah, the last mile connection to the Wi-Fi is the router. So router is a hardware. Yeah, so we have different hardwares. if in an organization setup, we normally have servers. Yeah, servers, we say that these are dedicated computers that respond to the requests of clients. So when you are seated in a networked organization, chances are there's a file server somewhere, there's a print server somewhere, there's a communication server somewhere. Yeah, so servers help us helps respond to the requests that we make or within the network. Like for example, if you want to request a Facebook page, yeah, what response is normally the Facebook server. Yeah, if you want to request for Google or Gmail, what response is the Gmail or Google server. Yeah, so if the server is not there, actually most of the communication is not going to happen within a network. So where you are seated, that is a client. You are the client. Yeah, you are the one who is requesting. So your computer is attached to the network. The form that enables us to link between the various components within the network is what we refer to as the media. It could be through cables, or we could connect through wireless. We have Wi-Fi's, and also we have the cables. Now remember our last discussion, we talked about the expansion slots, and one of them we said that the expansion slots that you can have is the network interface card. Yeah, so any component within a network must have this particular interface card so that they can be able to connect to the internet. It could be through the cable, or you can configure your network interface card to access internet through Wi-Fi. So hardware is one of them. When we talk about software, of course we understand that software it comes in different categories. We have application softwares, we have the system softwares, we have the programming softwares. We are going to look at softwares in detail later on. Now the main software within a network that makes network devices function is the network operating system. Like for example, in a server cannot operate without a network operating system. Yeah, so we must configure the network operating system within the server. Now this particular operating system is the one that is going to manage, yeah, the hardwares that are connecting to the server. Yeah, so any other resource that is connected to the server is going to be managed via the software. So this particular operating system is very, very important. We have examples of network operating systems that we have Windows Server 2012, Windows Server 2016, we have Linux, we have Unix, and so on. Now, when you want to access the server, of course you need to have client application software. Yeah, like this is a software that is going to directly communicate with the softwares that are installed within the server. So these are just examples of softwares that are needed within a network system. Remember the two items, hardware and softwares, are needed for a network to fully operate. Now there's a diagram here that summarizes how a network or a computer network looks like, or how a computer network operates. Now we have at the top, or towards the top left, we can see there's a smartphone. Also we have the laptops, and there's some kind of Wi-Fi signals, right? Now the Wi-Fi signals are actually emitted via the Wi-Fi router. So I believe you can see the Wi-Fi router. Yeah. Now Wi-Fi router uses the microwaves, yeah, to actually distribute the internet signal, or the radio waves for that matter. Yeah. So we say communication has been established using the Wi-Fi, like it is wireless. There is no cable. At the center we can see the router, the switch, and the server. Yeah, all those lines shows that the mode of the media that is being used is the cables. Yeah, so we can implement cable, and also we can implement the wireless options within the same network. A good example is Riara, yeah, whereby within the labs there are some cables connected to the machines, but outside or within the labs themselves, we can still access the internet by the Wi-Fi. Again, within this particular diagram, we have the server. I've just mentioned that this is a very important machine within the network. So the server manages different things within this particular network. Right now, we can't say which kind of server is this. We really need to differentiate the different servers. But from the setup, I can say that this is a communication server. Yeah. So communication server manages the communication between the different devices within a network. Again, for us to establish connections to multiple nodes or devices, we need devices such as switch. Yeah, a switch has multi-ports where you can connect different devices. At the bottom left, you can see we have the PCs. Yeah, PCs, if you are I don't know if it's visible, but you can see kind of a ring, yeah, connecting the PCs. Now the ring is a topology. Yeah, a topology is a blueprint of how connection happens within a particular network, right? So we're going to look at different topologies. Yeah, so we can have ring topology, star topology, and the rest. And of course, we have other connections. Yeah, we can connect to the scanners, to the printers, to the IP phones, and so on. At the top, we have the internet. And you should be very, very keen to see what connects to the internet. You can see it is the router. Yeah. So without a router or router, we can't connect to the internet. Yeah. So router is a very, very important communication device within a network. Yeah. So every time you want Wi-Fi connection to your house or to your homes, normally the internet service providers, they come to install the router. Yeah. So the router is the one that is going to help you access the internet, right? So we are going to look at the OSI model. OSI model gives us a framework of how the different devices communicate within the network. So we have the 7 layers, and router belongs to the third layer of the OSI model. Yeah. So I believe this one, this diagram is going to form a good foundation of how we are going to view the network, right? Good. So we have different types of networks, right? Networks are come in different ways. We can connect or have networks based on the geographical coverage. We can connect. We can have computer networks based on the purpose of which they are established or implemented. We can also have purpose. The operation functionality of a computer network matters a lot. Yeah. Now, based on the geographical span, we have different types of networks. We talk about LAN, MAN, WAN, PAN. We have CAN, and so on and so forth. Yeah. So the purpose of which you want to have this particular network will inform the kind of name you are going to give it. Like if you are at home right now, we are assuming that you have maybe a router connecting to 2 or 3, 4 devices. That means you are working under a HAN, home area network. If you establish a connection between you and your friend via Bluetooth, yeah, that is a network that has been established. So that one we say you have a personal area network established. In an office setup, yeah, in an office setup you can have connection between multiple devices within an office or a building. We refer to that as a local area network. If we expand the geographical area to a city, yeah, we refer to that as metropolitan area network. Of course, global area network is kind of also enhanced. Yeah, so it's more or less the same as the wide area network. Yeah. Now, so local area network. This one connects few users, of course, within a small geographical area. Yeah, I've just indicated like a size of an office, right? So it has its own pros and cons. The LAN, of course, WAN also has its pros and cons. So if you want to reach a wider geographical area, a wide area network is normally implemented. Of course, the far the connection, that means we need to invest in other technology so that we can transmit the signals. So here we need to have microwave satellite dishes, right? Also we can have internet service digital network lines actually implemented. Now, to access a wide area network, of course, normally when you subscribe, like let's say if Zuku are the ones who are your internet service provider, yeah, they can always connect you via the dial-up access or list line. Yeah. So normally most organizations, they use the list line option. This is whereby you pay, yeah, for some dedicated period of time, yeah, without actually like you can pay for the bandwidth for almost 2 years, yeah. So you can lease that line for that period of time, yeah. But some of us, we have dial-up access, yeah. Dial-up access is like you purchase some bundles, yeah. So you only visit, yeah, you only visit a particular internet when you pay for it, yeah. Whereas list line, it is there whether you use it or not, it's always there connected, yeah. So there's a bit of difference, but I hope you get the point. Of course, we have metropolitan area network. I've mentioned that area such as city, yeah. So we can have the multiple organizations connected together. Like for example, if we had Riara branches like 4 or 3 within Nairobi, we can connect it using metropolitan area network. If you access Wi-Fi or internet within the campus or institution level, we refer to that as campus area network. Of course, I've said that we have global area network. Now, the difference between global and wide area network is that global is kind of private, yeah. Like this NASA guys, they use a global area network, but somehow it's not publicly available for people like WAN is, yeah. Which other? Yeah, I've mentioned you can also have home area network, which is not covered here, yeah. So ensure that you understand the reason as to why we implement this type of networks. One, because of the purpose, yeah. Why do we need that particular network? First of all, and of course, the price also comes into perspective, yeah. Are you able to implement a WAN? Yeah. What are the reasons? Actually, purpose is the main reason as to why you will choose either LAN, WAN, MAN, and so on. To compare these 3 widely used options, LAN, MAN, and WAN, we can look at range. Of course, the distance of one is larger compared to the rest. Media used, you can say within LAN, we can use cables, yeah, and even we can use microwave, but majorly we can use cables, yeah. We use cables. For MAN, we can use Wi-Fi's, and WAN also we need to use unguided media. Now, it's about distance. Someone is going to ask, why can't we use maybe cables in a WAN? Of course, we use cables to access WAN, yeah. But where we have this particular servers or internet service providers, yeah, they are very far. So cables cannot actually support the transmission of what? Of data or signals, and that's why we don't rely on them over long distance. We talk about attenuation of signals, yeah. So we are going to invest more using cables when establishing a WAN rather than just using the unguided media, which is wireless transmission. Of course, speed matters a lot when it also comes to the implementation of these 3 options, yeah. I mean, purpose, what do you want, yeah. So if you frequently download things, yeah, or you want to transmit or actually send large files, yeah, so it depends with the purpose again. So the speed matters a lot here, but high speeds vary with the implementation of actually the devices that you have. Yeah, cost, I've said that when you want to implement one, that it's going to be very expensive based on what you have discussed. Of course, LAN is cheaper. You really don't need to have stuff such as servers and so on, right? Equipment, also we are going to look at the equipment based on the OSI model. Yeah, like the network interface card, you've already mentioned it, the switch, the hubs, this belongs to the LAN. Yeah, of course, as we proceed, we have the modem. Yeah, we have the synchronous transfer machines within the WAN. Yeah, the fiber distributed data interface and so on. Yeah, now the protocol, I've said that this is the engine that monitors or actually ensures that communication happens. It's a standard language that all the devices needs to understand. Yeah, so if we have devices from Linksys, we have devices from Cisco, we have devices from whichever manufacturer, we need to have a protocol that enables them to communicate within the network. And of course, lastly, we have the applications. Yeah, of course, when you move to one, we need to have sophisticated applications that are going to help people maybe access the internet and so on. So these are just some basic ways of comparing and seeing the difference between the three. Talking about or breaking the architecture of the network, we need to also understand the various components. I've already mentioned this, so I'll just highlight. So we need to have transmission media. Take note of that, very, very important. It could be cable or wireless. Reason, we need to transmit data. The other one, need to have clients. Yeah, otherwise you can't be able to access a network. We need servers, very, very important, right? For us to be able to access our emails, access our databases, access our printers, and so on. Node, I said that any device that is connected to a network, it could be a router, it could be a switch, it could be any device. That's the right term, the node. Yeah, so node is anything that is connected to the network. When you are remotely connecting to a particular machine, yeah, the machine that you get the resources from, we refer to that as the host. Services or network services, these are ways. Yeah, it's like I call them the tap. Yeah, you see, when you want to let the water flow, you have the water. You can have the internet, but if you don't actually open up the tap, so the services actually like they control, yeah, the kind of things that you're going to access, yeah, within a server. So if you want, for example, if you want to print, you could be having a printer, but if you turn off the print service, you can't be able to print. Yeah, so there are kind of programs that controls how we access the various resources within the network. Segment, yeah. Now, to separate the different parts of a network, we term or use the term segment. Like for instance, in a normal organization, we have different functions. Like we can have the HR function, we can have the finance function, we can have the ICT function. So to clearly implement network within this particular organization, we need to have segmentation. Yeah. So a larger network can be broken down into various segments. Yeah. So that you can have a way of securing the network. Yeah. Like for example, we can secure the finance network so that people don't really maybe know who is paid what, even the HR function and so on. So segment is very, very important to understand. Now, backbone, this is like a large cable. I normally use an example of not a large cable as per se, but I use the example of a fiber optic. Yeah, fiber optic normally is laid out of the outside the building in a form of a trunk. Yeah, so the backbone is the main cable that supplies the internet to various offices or various homes. Yeah, so of course, once you have the cable trunk, you can now tap. Yeah, every home can be able to tap to that particular backbone cable. Now, we have two types of LAN that we need to understand, because these are the foundation of any network arrangement. We have peer-to-peer network, and also we have a client-server network. Now, peer-to-peer, as the name suggests, yeah, these are set up whereby all the devices are the same. Yeah, but any device can be a server, any device can be a client. Yeah, so there's no one that controls the other, right? A client server, of course, the server there controls things. Yeah, it manages different responses from the client. Yeah, so talking about peer-to-peer, they're generally small in size. Yeah, like for example, in a lab setup, yeah, that is, we can talk about that as a peer-to-peer. Yeah, they're cheap to implement. Yeah, because there's no dedicated server required. Actually, everyone is the same. Connection can be both a server and a client. Yeah, so you can turn your computer to be to respond and to request at the same time. Of course, due to its small size, it can accommodate few users. Of course, since we don't have a centralized management component, the security is poor. Examples of operating systems that run under peer-to-peer could be Windows 10, Windows 7, and the rest. And I've mentioned it can be found within a single department, such as our labs. The opposite of peer-to-peer, we have client-server. Yeah, so here there's some kind of control mechanism. Yeah, so one computer plays the role of a server. There must be a computer that plays the role of a server. Yeah, so clients will request, servers will respond. Yeah, it offers better security than peer-to-peer because we have a dedicated server, right? Also, it supports more users compared to the peer-to-peer. Most likely, it will use the network operating systems, the ones that we have mentioned: Windows 7, Windows 2012 server. We can have Linux, we can have Unix, and so on. As long as it's a network operating system that has the capability of responding to the client request. Very good. Now, the blueprint, or how the network is actually laid or implemented, is what is referred to as the topology. Now, we have different types of topologies. Of course, we have the bus, a ring, tree, star, mesh, hybrid, and I believe we have others that have not been captured here. Now, talking about a bus, yeah, bus is a long cable, yeah, that looks like a bus. That's the name, yeah. And we talked about the backbone cable, so we can say that that is the backbone bus, yeah, like it is a long cable. We also have the tree. I think I have the diagrams. I'll show you now a while. But let's look at the fundamentals before we look at the nitty-gritties of these particular topologies. Now, when you connect two devices, like for example, when you're connecting one computer to the other, we talk of point-to-point communication, or connection for that matter. Yeah, point-to-point. Yeah, one computer, one computer. So there's nothing in between. Only two devices are linked. So that's one way of connecting to a topology. The other way is multi-point. Yeah, multi-point, whereby you can connect one computer to different devices. You can connect your computer, for example, to a switch. You can connect your computer maybe to a mobile phone or some gadget somewhere. Yeah, so you can connect your computer to a printer, to a scanner, and so on. So that one forms a multi-point. Yeah, now all these two connections, multi-point and point-to-point, they have their pros and cons. For instance, if we go back to this point-to-point, if there's a cut of the cable, let's say for example you are connecting two computers using a cable, if there's a cut, that means the two devices will not communicate. And of course, even if you're using wireless, yeah, and let's say we have a barrier between the two, then the wireless or Wi-Fi signals are not going to be, you can't be able to receive the signals. So those are the challenges. And of course, multi-point also has its challenge, like when the central device, yeah, that connects multiple devices, if it fails, then there are high chances that the network is not going to operate. So let's look at the different types of topologies. Of course, I've said that we have the layout, the actual appearance of how the network has been implemented. That's the physical. That is what you can be able to see. When you get to an office, you can see how computers are arranged. That is the physical arrangement. But of course, we have now the logical arrangement, how they have been configured to operate. Yeah. So that's how that one you can't be able to see. So that one referred to as the logical topology. Now, talking about the different types of topologies, you can see the star. Yeah. Star is connected to a central hub. The devices are connected to a central hub. Yeah. A hub is a device that actually connects multiple devices within a network. Of course, we normally say that we have active and passive hub, but forget about that for a minute. Now, this black box at the center here, it offers a way of connecting multiple devices. So suppose it fails, that means there will not we won't have communication between the different devices. But better still, if the cables or the connection to the main device fails, then communication to the other devices won't be affected, right? So let's see. Any volunteer to read for us star topology? Star topology.
I'll read for us. Star topology. Devices connected to a central point called a hub. A hub acts as the central point that collects and distributes data over the network. If one device connected to the hub fails, the rest of the network will continue working. If the hub fails, devices connected to the hub will not be able to communicate. Use Ethernet method of communication.
Thank you. Now, Ethernet method of communication is ideally, we call it is a communication whereby computers manage their communication process, like who is going to communicate first. Yeah, we call it the carrier sense detection mechanism. Yeah, so if you are given the priority to communicate, you communicate. That's what we refer to as the use Ethernet. So should someone asks you to state what star topology is, you should be in a position to do that. Bus topology, you can see the main backbone, yeah, the one that I was describing, right? So we have that particular wire. The wire actually is connected to multiple computers. So you can say if you have an issue with bus topology, bus wire, yeah, chances are maybe we won't have communication to the rest of the computers. Yeah, so it also has its pros and cons. Maybe you can look at that. Any other volunteer to read for us bus topology? Paul? I think Paul, if you can hear us, you can read for us, yeah? Paul Muya. I can see you are reading, but I think you have muted, yeah. Unmute your mic. I can see you are reading, but ideally it happens, yeah? Yeah, very good. Now you can read. Thank you.
Okay, bus topology. All network All network devices, e.g. computers and servers, are connected to a single linear cable, also known as segment or backbone. A terminator is fitted at both ends of the cable. If one station phase it does not affect the entire LAN. If the connection to one station becomes loose or breaks, the entire cable segment loses its connectivity. Hard to troubleshoot.
All right, thank you. Now, of course, I didn't mention about the terminators. Now, the terminators here actually prevents the ringing back of the signal. Yeah, you see, if we don't have the terminators, that means that the line will be congested. So the computers will feel that there's someone or there's a computer that is communicating. Yeah, so the terminators actually are fitted to prevent this particular ringing back of or bouncing back of the signals. Yeah, so that the computers doesn't feel that the lines are congested. So I think that's what I didn't mention. So that's bus topology for you. Of course, it's hard to troubleshoot, yeah, but you have the devices to detect where there's a cut within the cable or where there's a split of the cable, and it will give you some precise information where there's a problem. Now, backbones I've already mentioned. You can see how backbone, the fiber is connecting to two hubs. So we are assuming that the fiber optic has been put within the trunk. Yeah, then it connects to the various offices. So hub one is within a particular office A, and hub 2 is within a particular office B. Yeah, so it is used to interlink the other devices. So that's how we can implement a backbone or fiber optic cable. Good. Now we have the ring. We also have ring topology. Yeah, you can see the computers are connected in a ring format. Yeah. Now this particular topology is rarely used. Yeah, but of course, why is it not rarely used? Implementing it is not easy. Yeah, it's not easy to implement. But when it comes to fault tolerance, because we are going to look at it, we can have two rings. Yeah, the internal ring and the external ring. So if one ring fails, the other one is going to pick up, right? Communication here happens in form of bypassing or giving a token. So if you have the token, it's like a relay. If you want to run, you have the button. Yeah, so if this particular computer wants to communicate, they must have the token. Yeah, so token is how they identify the sending computer. So the rest will wait until they get a chance to transmit. Very good. Any other person volunteer? Let's have ring topology. Someone to read for us. Ring topology. Esther, you are the one who was asking the people to record. Can you read for us, Esther Moirori? Or you have read?
It's okay, I can read right now.
Yeah, read for us.
Ring topology. Stations are connected to each other in a closed-loop configuration. Neighboring workstations are connected via point-to-point link, forming a physical ring. Each station is responsible for regenerating and transmitting signals around the network to its neighbor. Use token ring mode of communication. Ring networks without a hub cannot transmit data if one station fails.
All right, thank you. So ideally, is basically you can see the two rings. There's one, the backup ring. Yeah, like if the primary ring fails, the other one is going to pick. Like I've said, rarely used, very expensive to implement, and very few organization actually uses it. Of course, we have mesh. I think I'll summarize this. Mesh, you can see the connection is in the form of a mesh. Every computer is connected, is almost connected to the other. I think we should have another line crossing to the other side. Now, mesh topology, almost all computers are connected to each other. Advantage one, it provides fault tolerant. Like if one connection fails, computer can always use another route. Yeah, it's expensive. You can see implementing all these particular cables makes it very, very expensive. Yeah, so again, this is how mesh is implemented. Of course, also rarely used because of its expensive nature, but it's the best. Yeah, if you look at major organization, they use that particular kind of implementation. And of course, in our internet setup, we have this mesh, whereby most servers are interconnected. We still have tree, as the name suggests. You can see the branches. Yeah, so we have the backbone cable in form of a bus, which is connected to the it looks like a star. Yeah, so it's a combination of bus topology and star topology in a way. So that forms a tree topology. So we have already looked at the pros and cons of star and pros and cons of bus. So you can always tell as more about a tree topology. We have hybrid. Yeah, hybrid is where we combine also multiple. Yeah, we combine multiple topologies. Like you can see, there's a mesh topology. I can see, there's a ring topology. I can see there's a bus topology. I can see there's a tree topology. So any other topology that you can add there brings or forms this particular hybrid. So hybrid is where we have like for example, in a department, in an organization with multiple departments. So one department can implement a tree topology, the other one can implement a bus topology, the other one can implement a ring topology, and so on. It's based on the purpose of those particular functions, right? Very good. So I think that will mark the end of the topology. So let's have a look at the transmission media. As I indicated, we have cables and cables, form of connection. Yeah, guided media, we have twisted pair cable, coaxial cable, fiber optic. Of course, within this particular array of media, we also have different categories. Like twisted, we have the untwisted pair cable. We have different categories. Yeah, but you're not going into details. And guided, we have mentioned the satellite radio, microwave, and so on. Yeah, you can see the pictures of these different types of guided media. I believe the twisted cable looks familiar. They are coaxial also. Fiber, I don't know how many have laid their hands on a fiber cable or have seen one. But of course, they are rarely used because of their backbone nature. Yeah, they are implemented within the trunks. Yeah, so if you see those guys digging around your house or homes, actually installing the fibers, you can take a look at that. So they have their advantages and disadvantages. We are not going to look at that. I only want you to at least identify 2 or 3 examples of guided media. We also have unguided media, use of waves. Yeah, so we have the satellite dishes that actually relays these particular waves from one part of maybe the country to the other. Like Safaricom implements these. I believe also these other telecommunication stations have this kind of transmission media. So they are very expensive. You can imagine having the satellite dishes from one place to the other, and that's why sometimes people complain that this side of the country we can't get the signals. Yeah, so that means maybe those particular companies have not implemented this particular satellite. So this is how it looks like. Of course, satellite means up, far from the earth. Yeah, we have transponders between the satellite dish, satellite that has been implemented. Yeah, you can see IMX, and you also have the hub, right? So satellite is there to boost, yeah, to boost the signal from one satellite dish to the other. Yeah, of course, that's all about guided and unguided. Yeah, so if someone asks you to talk about guided, you can just mention the few cables, or unguided, mention the few options that you have discussed. We have protocols, yeah, and I think if we talk about protocols, last time we looked at the brain of the computer, and we said the brain of the computer is the CPU. Yeah, now when it comes to communication within the network, I look at protocols as like blood, yeah, that flows across all parts of the body. Yeah, so blood doesn't really say that out flow through my legs or so on. So protocols is a standard way of communication within a particular network. Yeah, so when you are in a place where people are talking different languages, right, they communicate, they don't communicate. Why? Because they can't really get to understand what they're saying. But protocols are here to define a standard way that this particular devices can be able to communicate. So this is done by use of roles, yeah, that they have to adhere to. So we have different standards of protocols, and we are going to be guided by the OSI model. Yeah, so this OSI model, open system interconnection model, this is a model that summarizes how the architecture of a network looks like. Yeah, so any communication, any network connection is based on this particular OSI model. Yeah, so we're going to look at step by step at the 7-layer model, right? Like we have the physical layer, we have the data link layer, we have the network layer, we have the transport layer, we have the session layer, presentation layer, application layer. So let me just give you assist you of how we can understand this. Yeah, now since you have said that this is the blueprint of how communication within a network happens, you need to understand the devices, yeah, the devices that operate within these 7 layers. You need to understand the protocols that are found within the 7 layers. Yeah, like for instance, you need to understand actually the 7 layers themselves. Yeah, so I normally use the acronym, or actually you can find a way of remembering them. Like from top up to top bottom, you can have all people seem to need data presentation, something like that. Yeah, so just to allow you to know which layer you are talking about. From bottom up, I normally say, please do not throw sausage peas away. This is just a way of allowing you to understand the 7 layer. Yeah, so once you have understood how they are called, or which is number 1, which is number 2, 3, then now you can go ahead and understand what is inside them. So let's look at the 7 layers, starting with the physical layers. Of course, the physical layers, we are going to be guided by the protocols themselves. Yeah, the protocols are based on the network type, the manufacturer, hardware, and so on. Now the physical layer, you can see it is the first from the bottom, yeah, not first from the top. So physical layer, let's identify the protocols first. Yeah, so the protocols are based on the IEEE 802 series. IEEE Institute of Electrical and Electronics Engineers. Yeah, so this is a body that comes up with the protocol that runs within the physical layer. Now, when you talk about Wi-Fi, when you talk about cables, when you're connecting computers, this happens within the physical layer. It is the connection point. Yeah, that's why it's largely mechanical, electrical, and has the timing. Yeah, so someone is going to ask you, yeah, that you get into a room, then you find that the cable is not connected to the computer. Then they ask you which particular OSI layer could be affected. So that means if there is no connection based on the cables, that means it's the physical layer that has been affected. Yeah. Now, transmission of data at this point happens in form of bits. Yeah, and you see bits, these are like machine language, ones and zeros. Yeah, so here is where the modem comes into play, where they convert the analog signals into digital signals, bits, right? Data link layer is the second layer from bottom, right? Now this, let's look at how data is transferred. Now data is not transferred in form of frames. Yeah, still the protocol type is under the 802 series. Yeah, and now we have two sub layers. Now sub layers actually refers to how this data link is configured. Like for example, if you connect or implement computers within an office setup, yeah, normally the MAC addresses are used, yeah, to ensure that communication happens between those particular computers. So the MAC addresses sometimes is called the hardware. Yeah. So if you have your computer, if you go to the command prompt, the CMD, if you type the ipconfig, you will see the MAC address. Because we are not in an ICT class, let's just understand that we have the sublayer, the two sublayers, logical link and the sublayer link. Now the logical link is where the frames are transformed to packets, or packets are transformed into layers. Packets are in the third layer that you're going to look at. Our devices under this particular layer, we can have the switch, which offers the connection between multiple computers, or bridge. Yeah, bridge is like a hub. Yeah, it also has 2 or 3 4 ports that connects 2 or more computers. So talking about a frame is how the data is presented within the second layer, right? And here data can be identified. If you are sending or transmitting data, yeah, you can encapsulate it with this kind of information. Yeah, so it can be given the destination address where the data is going. Like for example, if the data is meant to go to computer C from computer A, so the destination from computer C is going to be appended. The source address from where it's coming from, computer A, is going also to be appended on that particular frame. The data itself, yeah. Now we have the frame sequence check. Frame sequence check is an automated process whereby the data is checked for any irregularities. Like for example, if you send a 7-bit data, is it going to arrive there 7 bits or 5 bits? So this frame sequence check is just to ensure that the frame has arrived the way it was sent. And of course other elements. These protocols that enables this particular operation to happen, we have the Ethernet. Remember how the communication happens. We also have the token ring. Remember the ring topology, where you need to have the token for you to be able to send, as if you're a computer. We also have fiber distributed data interface in case the connection is via fiber. And of course we have the series, the 802.11 series, yeah, based on the Institute of Electrical and Electronics Engineers. And finally, the protocol, point-to-point protocol that allows us to send data between two devices within layer 2. The third layer from the bottom, we have the network layer. Of course, here is where now you access the internet. Yeah, so always remember the third layer as the internet layer. Yeah, so without router, remember the device that operates at this particular layer is the router. So when you're configuring the router, it now configures you to access the internet. Now at this point, the data is now transformed into packets. Yeah, packets also has its way of packaging the data. Yeah, now remember the logical sub layer that we talked about in our previous layer. So this is where it translates the logical address into physical address, right? The action here is routing. Yeah, so this particular layer has the capability of identifying the destination device. Yeah, so it is it's a very intelligent layer. That's why we use the router. Router is very intelligent. Yeah, so if you want to access or send data, yeah, if you want to email someone, yeah, it can route that particular email to the right address and so on. So it plays a very major role within the network system. Of course, I've mentioned the packet. We have the packet header addressing information. So we just add to the top of the frames. Source address, destination address should be added here, and so on. Of course, the network layer protocols. We have the internet protocol. I believe this is the famous, the IP address. Almost every device that connects to the internet must have the internet protocol. And of course, we have other protocols such as the open shortest path first protocol. We have the border gateway protocols and other protocols that assist in accessing the internet. The fourth layer is the transport layer. Yeah, the name suggests for itself, transport. It transport. Yeah. Now look at the way data is transmitted. Segment. It identifies a segment where this particular data should actually go to. The good thing with transport is that it offers acknowledgement of received segments. So we're going to look at the different types of protocols. Actually, there are only two, UDP and TCP. So transmission control protocol has the capability of telling you that the recipient actually received the data that was sent, or it didn't, or they didn't receive. Yeah, and also it offers proper resequencing of segments. Like for example, if this data was made of 4 segments, A, B, C, D. Yeah, they have to arrive at the destination as A, B, C, D, and not D, B, C, D, right? And of course, the famous devices within this particular layer, we have the router, yeah, bridge and accommodation of a router. We also have the gateway. Yeah. Now, most importantly, is you to really identify the two protocols. Transmission control protocol offers acknowledgement of what? Sent data. We also have user datagram protocol. This one doesn't offer acknowledgement, in that whether your data or your email or anything that you sent was received or not, it doesn't tell you. Yeah. So those are the two protocols. Then we have the session layer protocol. Session layer within the OSI model. It provides different sessions. Of course, this is establishing communication channel between one device to the other in form of sessions. Like if someone tells you, we have a session, a 2-hour session to talk about computer sessions. So that is a session, 2-hour session. So that means you have a starting session, yeah, what you're going to talk about during the session, and terminating the session after the 2 hours. Yeah. So how is this session going to happen or implemented? So you can have a simplex. Yeah. Only one device transmits. Yeah. You have to wait until I talk. Once I've finished talking, is now when you can be able to do what? To talk. Yeah. Then you have half duplex. Half duplex is like you're giving each other 50-50. Yeah. Like I talk, then it's like a walkie-talkie. Yeah. Walkie-talkie. Yeah. So each side takes turns transmitting. Full duplex is like a mobile phone. Yeah, someone can talk and you can also talk at the same at the same time. So when connection is established, it's established in 3 phases. You have to establish the connection, right? The data transfer, and also the connection needs to be terminated, right? So if the connection is not terminated, chances are this is a point where the hackers get a chance to use the unterminated connection. Like for example here, we are using Google Meet. So there's a session that Google Meet has given us. So if we happen to leave and we don't close, so chances are someone can invite themselves to this, and if I happen to share my screen, they can view whatever is within my desktop and so on. So it's important to obey the sessions. Yeah, always terminate. Though there are softwares that terminate themselves if they are idle for some period of time. Yeah, so like for example, if you have opened your Gmail and when it's idle for some time, it logs out itself. I believe you have experienced such. So devices here are gateway. Gateway is an improved router. Yeah, improved router means that it has some additional configuration settings to handle the sessions. Of course, we have the active server pages and the net bias for the session layer as the protocols, right? So this one enables, as you can see, active server pages. These are web-based. Yeah, so they maintain the connections or sessions within the web or the websites that you use. We also have presentation layer. The term is presentation. How is data presented to you? Is it in video form? Is it as an image? Is it in text based? Yeah, so these are ways, or it defines the syntax that network hosts use to communicate, right? So the main thing here is encoding or encryption. Yeah, so you can see the major types of presentation of data. It could be in the form of image and so on. We also have the protocols at this point. We have the secure socket layer. Yeah, we have the multiple internet exchange something. Yeah, but what we normally use is the secure socket layer for our websites. I believe you have seen maybe before your image or the website actually downloads or actually you upload, there's always some kind of security layer that is normally appended to your network, just to ensure that whatever you download is secure, or whatever website you access is secure. And I believe lastly we have the application layer. Yeah, now the application layer is now we're going to look at the different softwares. An application layer is that particular layer that the user interacts with. Yeah, so most importantly, this particular layer is going to give you what you need. You want to download a file, it gives you that. You want to what else? You want to receive email, so it does things for you. Yeah, you interact with it. If you send, that layer does the sending of the email for you. Yeah, if you want to listen or listen to music, that application does that for you. Yeah, so we have the different protocols that always ensures that we have this particular layer operate successfully. Of course, you have the dynamic host control protocol. So dynamic host control protocol, this is a layer. This is a protocol that enables you to quickly identify a particular internet protocol. Yeah, like for example, if you go to a Wi-Fi area, yeah, it is the DHCP that gives you that connection automatically. Yeah, so yours is just to be given the credentials, but it's the one to connect you. Yeah, so that's why it's dynamic. It checks the available devices and connects you. If you want to download files or transfer files from one point to the other, we have the file transfer protocol. Now we have the receiving and the sending. emails. So we have the simple mail transfer protocol. Yeah, so this is when you want to send emails, it does that for you. Then we have the post office version 3. If you want to receive the emails, it does that for you. And of course we have the secure HTTP and the unsecure HTTP. It allows you to browse across the different websites. So ladies and gentlemen, I know I've really taken you through a marathon. It's only that I want to give you a chance to digest what I've explained. Now, that will mark the end of the computer networks. Remember, I have not gone into details because we are really not here to look at the